Hello, and welcome to Backer Breaks It Down. In this episode, we're going to talk about inverse tangent, inverse sine, and inverse cosine. You're probably wondering what inverse means. Okay, well, looking at our little comic, notice this word right here, angles. So I can use an inverse trig function to find an angle measure. How about that? Like we've used the trig functions to find missing sides, this is saying we can totally use these trig functions to also find angles. We just have to use their inverse, okay? So just remember, since we're going to be calculating, check your mode on your calculator right now. Make sure degree is highlighted because you don't want to go doing all of this calculating and be in the wrong mode. You'll feel like this guy, okay? All right, so inverse tangent. The inverse tangent of x is the measure of an acute angle whose tangent is x. Okay, makes perfect sense, right? So symbolically, this is what it's saying, that the inverse tangent of your ratio equals the measure of your angle. Now to calculate these measures, there's a button on your calculator, it says second. And then you're going to follow that up with whatever trig function that you're using, and then you're going to type in your ratio. Students often ask me, they're like, I never know when I'm supposed to use the second button, to which I usually say, wait a second, I don't know the angle measure. And I'll say that enough that it will stick, okay? That's when you use the second button. That's when you don't know the angle. Okay, wait a second, I don't know the angle measure. Okay, so taking a look at example 3, it tells us to look back at examples 1 and 2. I already posted that below, and calculate the measure of angle D and the measure of angle E to the nearest tenth of a degree. So when it comes to angle D, I can say that the measure of angle D is going to be equal to, well, I previously said that tangent of D was equal to 4/3. So now I'm saying that the measure of angle D is equal to the inverse tangent of 4/3. So try that on your calculator right now. Second tangent 4/3. Right? Did you get 53.1? Because if you didn't, you should probably try that again. Okay. Here's another question. Do we have to simplify the ratio before we go calculating the inverse tangent? Okay. So like what I'm asking is, could I have used like 36/27 instead of 4/3 and gotten 53.1? Yes. Okay. So that's nice. Like we don't have to simplify the ratios before calculating the angles. Like that's really nice. Right? Let's try it one more time. Find me the measure of angle E, because like this ratio is saying that the measure of angle E is going to be equal to the inverse tangent of 3/4. So try it out. What do you get? Really? You got 36.9? So did I. Way to go. Okay. So if you're thinking, hey, is there an inverse sine and an inverse cosine? Yes, there is. Isn't that what my title was all about too? Yeah. So there is an inverse sine and there is an inverse cosine. And so in these two examples here, we actually have to think like, ooh, which trig function am I using? All right. And so basically identify the angle you're trying to find. Ask yourself, what do I know? Right. And so angle L is what I want to find. And I know the opposite is 8. And I know the hypotenuse is 9.2. I want to know the measure of angle L. So how can I find it? So which of our trig functions uses opposite hypotenuse? You are absolutely correct. Sine uses the opposite in the hypotenuse. Okay, so I can say that the measure of angle L is equal to the inverse sine of the opposite over the hypotenuse. So the inverse sine of 8 divided by 9.2. So try it on your calculators right now. Are you going to get the same answers that I got? Yeah, because I got 60.4. So did you? Excellent. Oh, and if you didn't, remember, wait a second, I don't know the angle measure, so you need to go second sine of 8 over 9.2. Okay, taking a look at problem number 8, we want to find angle P. What do we know? Well, we know the adjacent side is 4. We know the hypotenuse is 13.6. We want to know angle P. How can we find it? Which trig function works? Hypotenuse adjacent. Hypotenuse adjacent. That would be cosine. So I can say that the measure of angle P is equal to the inverse cosine of the adjacent 4 divided by the hypotenuse of 13.6. So second cosine 4 over 13.6, what'd you get? 72.9. Me too. And so that's how we can use our trig functions to find missing angle measures. Make sure you are calculating in degree mode. Remember to use the second button, because wait a second, I don't know the angle measure. And it's just the second button, your trig function, and the ratio, boom, there's your angle. And that's how Backer breaks it down.